Good morning, everyone. My name is Mandre Priyanka from SVPM College of Engineering, Maligaon. Today, I am excited to present my internship project, the simulation of a washing machine using PixSim Lab, completed under the guidance of Immertex. Table of content. In this presentation, I will cover an introduction to the project and the C language, the microcontroller section, specifically the PIC60F877A, the software requirements like MPLAB X and the hardware peripherals used such as the CLCD, fan and buzzer. Things learned during internship. This internship was a great learning experience. I gained a strong foundation in C programming, understood the core concept of embedded systems, and learned how to implement real world projects using industrial tools like MPLABX IDE and PixSimLab. Introduction to washing machine. We all know washing machines are essential modern appliances. They have evolved from manual labor intensive machines to smart electronic devices that can practically wash clothes for us with the push of a button. What is an embedded system? At its core, an embedded system is a combination of hardware and software. We program this system using embedded C to perform specific tasks. Common examples include washing types of machines, embedded air conditioners, by and performance and refrigerators. Functional requirements such as real-time, standalone, networked, or mobile systems. By microcontroller performance ranging from small scale to highly sophisticated systems. Basics of embedded C. Embedded C used to design microprocessor based systems. These systems are built to perform dedicated functions either as a standalone device or as part of a larger system to carry out computations for real time operations. Blocks of an embedded system. Looking at the architecture, a typical system starts with a sensor that sends data to an ADC, analog to digital converter. This data is processed by the processor ASIC and stored in memory. Finally, the signal goes through a DAC to trigger an actuator which performs the physical work. Microcontroller versus microprocessors. It's important to know the difference. Microcontrollers are all in one chips, single chip, with a simple architecture designed for specific tasks. Microprocessors have a more complex architecture and require external peripherals to be interfaced to function. Keywords in C. Finally, to program these chips, we use standard C keywords. These 32 reserved words such as if, while, int, and wide from the basic syntax used to write the logic for our washing machine simulation. Data types. To start, every C program relies on data types. We categorize them into primary like integer and characters, derived like arrays and pointers, and user-defined structure that let us group different data together. Operator in C. Operators are the verbs of our code. We use arithmetic for math, relational for comparison, and logical operators to handle the decision making logic of our system. Project requirements. Our main goal is to simulate a washing machine. We are using the PIC60F877A microcontroller and developing the logic within the MPLAB X environment. MPLAB X is our development hub. It's a professional grade software by Microchip that allows us to write, debug, and manage our embedded C code. PixSimLab. Since we are simulating the hardware, we use PixSimLab. It provides a virtual board so we can test our code in real time without needing the physical components immediately. MPLAB XC8 compiler. The XC8 compiler acts as the translator. It takes our high level C code and converts it into the machine level instruction that the PIC microcontroller understand. Components used PIC60F877A. Their hardware and architecture. The PIC16F877A is the brain of our machine. It's an 8-bit RISC processor with enough memory and input-output pins to handle all the washing cycles and sensors input. Block diagram. The diagram shows our system flow. We have switches for power and navigation as inputs. The microcontroller processing the logic and the display, buzzer, and motor as our primary outputs. Timers are critical for washing machines. We use them to manage the duration of wash cycles and to generate PWM signals to control the motor speed. CLCD character LCD. Finally, the CLCD is our user interface. It's a 60 into 2 display that tells the user exactly what's happening, whether the machine is washing, spinning, or finished. Buzzer. The buzzer acts as our audio notification system throughout the washing cycle. It triggers an alarm if the washing machine door is opened during operation. Finally, it provides a 3-second alert to signal that the wash cycle has been successfully completed. Fan. In this simulation, we use a fan to represent the physical movement of the washing machine drum. The motor spin begins immediately when a washing mode is selected and stays active until the end of the cycle. For safety, the motor is programmed in stop instantly if the door is opened and will only resume once the door is closed. Conclusion. In conclusion, this PixSimLab simulation was a highly effective way to apply embedded system concepts to a real-world scenario. It provided essential hands-on experience that bridged the gap between theoretical code and practical hardware control. This project now serves as a solid foundation for our future work in automation and advanced control system. Thank you.
We load a file first. Here first we use a PixGenius board and microcontroller, that is a PIC16 F877A. When we open a file, we see press key 5 to power on washing machine. As I first said, we use key 5 for turn on the washing machine. It is powering on the washing machine. Now we again to press key 5 to it. Now it shows the programs of washing programs. To select the washing program, we use key number 4. Here we select delicates. To select delicates, to scroll down we use key 4, and to select it we need to press it long time for long. Long press for now to water level. Now we can see the water level. Same to scroll down we use key 4, and to select it we need to press it for long time. Here I select high water level. Now we see two switches. First one is to start and second is to stop. When we start, the fan starts. To stop, when we press switch number 6, then the washing machine come back, it come back to the functions. Okay, now I press key switch number 5, that is RB4. The washing machine starts. Program is delicate and it takes time for 31 seconds. Okay, here we can see if I press RB0, that is switch number 1, that means door opens. Okay, we see if we press RB0, the here we can see on CLCD it shows door is open, please close it. If we unpress the switch, it stops and function carry on. When the program is completed, we can see there is code that it shows program is closed, please take off the clothes, and that's it, and it restarts. Now I will show you the project.